let's say robots. Those are robots. Tesla robots. So Tesla, it is the first company which automates all things from the starting point to the end point. They automate all things. So you will see actually the robots are doing the whole job. So you have just some people there controlling those things, but robots are doing the whole job. You will see it, and they are working very in a very good way, because actually Tesla produces many cars a year. So they are doing a very good job. So from this video I will explain what is degrees of freedom, and you may see directly what robots are used for. From this video you see, so the whole process, they automate the whole process, you see. So everywhere, robots are everywhere here in Tesla. All of us we know Tesla.
Yeah.
So you see that those robots were moving in a certain way. They could not move like in any way, like as they, I can say, as you wish. You can't move a robot as you wish. So they must be, somehow the robot must move. In order just for a robot to move, we must have what you call degrees of freedom. What is degrees of freedom? Like, you know, like your arm here, you can move up and down. Maybe this one also can move up and down. You can spin it a bit, and those are degrees of freedom. Like, you have know about degrees of freedom by just seeing how your arm, maybe your legs are moving, and you know already what how many degrees of freedom do you have. That's the main characteristic of a robot. You must know the degrees of freedom for robots, not just for a robot to execute a certain task. You see those robots in Tesla were moving like, it will pick maybe a car from here and it will move in a certain way in order to place it somewhere else. So that robot must have degrees of freedom, like in which area that robot will move, and also to pick how it will do that. The robot will do that. So we must have degrees of freedom. Let me show you one robot which has 6 degrees of freedom, and you will understand a bit what I'm saying about these degrees of freedom, and they are even explaining. So hope you are seeing. So you see the first degrees of freedom, you see it moves like that. That's the first degrees of freedom. It rotates like this, the first one. The second one, it moves like that. It moves up and down. That side, it moves like so. You see, 6 degrees of freedom. How much? Let me. It rotates. The first degrees of freedom. It moves up and down. The second one. And also there is another. I will explain a bit about that. This is there is in robotics we have those 2 things. We have joints, and also we have joint and links. So when we are talking about joints we determine joint and links, like joint and links together, all together, we determine how many degrees of freedom you will have. You see? So you have that 3rd degrees of freedom, you have the 4th one and the 6th one. That's it. Imagine you have 6 degrees of freedom there, and it is a kind of I can say very big to have that kind of degree, those many degrees of freedom like that. But there is a certain robot, which is called PS2. That robot can have up to 32 degrees of freedom. Yeah? You can use Windows. You can use Windows. but the best to use is Linux. You see? So, in order just to run Linux on my computer, because I need also Windows, we have so many free apps. I cannot say that I will no longer use Windows. I still need it. So I installed a VirtualBox so that I can use also Linux on my computer. So I have a VirtualBox here. This is a VirtualBox. I'll show you how to install all those the VirtualBox. Even not today, but it is a process. I can show you how to do that. And yeah, you must make sure just to have like your computer has some good characteristics, like your RAM. You can have 8 GBs. You can work properly. Not the one for ROS does 2 GBs. So it can't run this VirtualBox, this Linux. Yeah, it can overheat actually. So you must also make sure you have like 500 GBs on your hard disk or your soft disk. Yeah, you see, it's another computer. I put the password and all that. It's another computer in my computer, inside my computer. So my password is John C. Mwaura Kinyanju. Yeah. That's it. So you can robot operating system. You can use two languages. You can use either C++ or Python. But Python is a bit simple than C++. Python, it's simple and it has also. I know some of us also can have their preferences. Maybe you may need to use you want to use C++ instead of Python. But for me, as for me, I like using Python than C++. Let me show you these codes. Let me explain to you these codes. So here you have a Python code in robot operating system, using that syntax for robot operating system. So you have first of all, you must call this import. It's like a kind of a library. You remember in C++ we used to call libraries. If you will use like this kind of a sensor, or you will do this kind of program, you must call a library. So this is a library, and from LCLPy, it's a library used in robot operating system. So you import nodes. You remember nodes? I told you about nodes. Nodes, it's a kind of a code which you can use to automate to do a certain task. You see? So you have like your this is a simple code. In Python, we created a class. I told you about the class. A class, you will learn more about it. I'm just giving a simple explanation so that you can like have an idea about class. But as we are moving on, you know what is a class and how maybe to put something in a class, how to create a super class, how to create all those things. You see, when you have a super class here, this is a super class. And then you can that class you can inherit from this class, because that is your super class. You can inherit from this class. If you want maybe to use a certain variable in this class, in a certain function, a certain variable in this class, a certain part of the code in this class, you can just inherit from this class and you use it at another place, another class maybe. So you have here. In a class we have what you call self. Self is like in this class you have some you have characteristics of that class. So you call that class by using you call a certain characteristics in that class by using self. You see? So you have like self creates timer, because in the class you have yourself here, and then you will call you say self creates timer. This is that means in this class you have you created a timer. You see, self counter, self get long, self keep moving. So for this code, let me explain a bit. This code will just print on my screen hello from ROS 2. Hello from ROS 2. How it will print it? You created the your super class. Your super class will be your first node, and then you have your timer. You have your timer so that it will not be printing like it will be printing one after the other. Like it will print hello from ROS 2. It will have some time, resting time, and then it will print again hello from ROS 2. You see? So you must create a timer for that, and you must always call back. That's code in order just to print your hello from ROS 2. So after that, you have the timer callback. As I told you, you have the timer callback. You must always have the self. You see, and then you count self counter. That is an incrementation. You know what's an incrementation? It will be like it will be called for the first time, and it will be called it will increment, not just to be called for the second time. Like you printed the first time, and then you print again the second time, and it will go in that way. So here, those are particular for the robot operating system. You have your spin. Your spin, when you have in your code, you have while loop. You know a while loop. While loop, it is used to have a loop. To have a loop, like to have a certain code which is executed several times in a loop. But for robot operating system, we have what you call spin. So it will be spinning, like it will be doing the same thing over and over again, up to when we say stop. You see, that's how a robot works. And then you have also shuts down. Like it reads first of all, it shuts down, and then it will go back because you have that spin. It shuts down because it will I can say finish executing the first code, and then it will spin again. You see? So that's it, and then you have your man. So in robotics, that's a knot. I will try to let me simulate it so that you will see. Let me simulate. Sorry, that's the wrong passwords.